In this video, we are discussing about Argand plane and polar representation of a complex number. See, consider two mutually perpendicular lines. Consider two mutually perpendicular lines in the plane. Then these lines are called coordinate axes. In this, the horizontal line is called x-axis. The horizontal line is called x-axis. The vertical line is called y-axis. The point of intersection of coordinate axis is called origin. These coordinate axes, the mutually perpendicular lines, nothing but the coordinate axis, dividing the plane into four parts. Each part is called quadrant, namely first quadrant, second quadrant, third quadrant, and fourth quadrant. And corresponding to every order pair, there was a point in the plane. For example, 2, 3. So from origin to x-axis, 2 units distance. Just take this is the point to 2 units distance from origin to upside vertical side 3 units distance. The point of intersection of these 2 points give a position. That position is called point 2, 3. So these things already we know. We studied in coordinate geometry. That is Cartesian plane. Nothing but Cartesian plane. In Cartesian plane, already we studied about this. Now, what is the Argand plane? What is the Argand plane for a complex number? So the general form of complex number is z is equal to x plus I. The complex plane, the general form of complex number is in the form of x plus I. Here x is called what? Real part. Y is called imaginary part. What is x? X is the real part. What is the y? Y is the imaginary part. Corresponding to every real number, every complex number, there was a point in the form of x comma y. So remember this. What is that? Every complex number expressed iy, there is a point. That means every complex number is associated with a point x comma y. And you take the x-axis as a real axis. And y-axis you take as imaginary axis. What is that? The horizontal line I am taking as a x-axis. The vertical line I am taking as a y-axis. Then this plane is called Argand plane. If we taken x-axis as real axis, y-axis as imaginary axis, then the plane is called Argand plane. Right? So every point, every complex number expressed iy is associated with the point px comma y. So you see, for example, z is equal to 2 plus 3 I is there. What is the point? Point P is equal to 2 comma 3. So we are representing like this. This is the point 2 comma 3. If it is minus 2 comma 3, we are representing in the second quadrant. Minus 2 comma minus 3i, that is third quadrant. Next to 2 minus 3i, that is the fourth quadrant. Right? If z is purely real means what? Imaginary part is 0. That is the complex number is x. Z is equal to x. So x plus I into 0. So x plus, that means if real part, imaginary part is 0, nothing but the complex number is purely real, then the complex number then the complex number is present on x-axis. If x is positive, lies on positive x-axis. If x is negative, lies on negative x-axis. Next, if z is purely imaginary means real part is 0. That is iy. This is nothing but 0 plus I into y. This one lies on y-axis. If y is positive, lies on the positive axis. Y is negative, lies on the negative y-axis. Right? This is the introduction about Argand. So next, you see one example. Draw the following complex numbers. Point out the following complex numbers in the Argand plane. First question, 1 plus 2i, second one, minus 1 plus 3i, fourth one, minus 1, minus 2, minus 3i, next to fifth one, this is third one, fourth, 2i, fifth, 6, seventh, 2 minus 3i. So you take one graph, x-axis, y-axis, Argand 1, 2, 3. Next to here 1, 2, 3. Here minus 1, minus 2, minus 3. Next to here 1, 2, 3. Minus 1, minus 2, minus 3. That is the negative x-axis. This is the negative y-axis. First one you see 1 comma 1 base 2 means what is the point? P is equals to 1 comma 2. 1 comma 2 lies in which quadrant? First quadrant. So 1 comma 2 here. This is the point P. If you take as P1, this is the P1. This is P2 is equals to minus 1 comma 3. P3 is equals to minus 2 comma minus 3. P4 is equals to here. This is 0 comma 2. P5 is equals to 6 comma 0. P6 is equals to 2 comma minus 3. So you point out in this graph. So first P1, this is the P1 point. P2 is minus 1 comma 3, minus 1 no, comma 3. Here, there is the point P. Next to P3, P3 is minus 2 comma minus 3, minus 2 minus 3. This is point P3. Next to P4, 0 comma 2, 0 comma 2 lies on y-axis, positive y-axis. This is P4. P5 is 6 comma 0, 6 comma 0 lies on positive x-axis. Next to 2 comma minus 3, 2 comma minus 3 fourth quadrant. So this is P6. Like this we are presenting in the Argand plane. Right? This is the introduction about Argand. Right? Next to how we are representing a complex number in polar form. And that is our next topic. How you see? Again, you take one Argand plane. You take one Argand plane here. X-axis, y-axis, Argand. Right? So this is the one of the point. P is x comma y. P is x comma y means what is the complex of this point? That is z is equal to x plus I. Right? Z is equal to x plus I is the one of the complex number. Its point. What is the point in Argand plane? X comma y. This is x comma y. Next the origin to point you take as r. Origin to point P. The distance I am taking as a r. Next the angle between positive x-axis and OP is theta. It is measured in anti-clockwise direction. This is theta. Next you draw a perpendicular line from P to x-axis, that is PM. Right? Here OM distance nothing but x coordinate of P. So this is the x. PM nothing but the y coordinate of P. Now you take one right angle triangle beside here OPM. This is R, this is the X, this is Y, this is the angle theta. Angle theta. This is the one of the right angle triangle. So from the Pythagoras theorem, OP square is equals to OM square plus PM square. OP square is equal to R square, OM square is X square, PM square is Y square. So R is equal to under root of X square plus Y square. Okay, we got R value. Next, from this triangle, cos theta is equals to what? Cos theta means adjacent side by hypotenuse. Adjacent side is OM. OM is equal to X. Hypotenuse is equals to R. So from this, X is equal to R cos theta. X is equals to R cos theta. Next, from the same triangle, sin theta is equal to sin theta is opposite side by hypotenuse. So that is the opposite side length is y, hypotenuse is r. So y is equals to r sin theta. R sin theta. Now you substitute x and y in this. So z is equals to x. X is r cos theta plus I into y r sin theta. R sin theta. You take r as a common. Cos theta plus I sin theta. Z is equals to cos theta plus Z is equals to R into cos theta plus I sin theta is the polar representation of a complex number. For which complex number? Z is equal to X plus I by. Here what is the R? What is the R? R is under root of X square plus Y square. Nothing but modulus of complex number Z. Next to theta. Here theta is called what? Amplitude or argument of Z. Here theta is called what? Amplitude or argument of Z. It is denoted by amplitude AM of Z or argument ARG of Z is equals to how we are getting to see tan theta is equals to what? Sin theta by cos theta. What is the sin theta? Sin theta is y by r, cos theta is x by r. R get cancelled, which is equals to y by x is equals to. That is tan theta is equals to. From this theta is equals to tan inverse of y by x. Tan inverse of y by x. So that is theta is equals to what? Tan inverse of y by x. Theta is equals to tan inverse of y by x. Remember this. See now, what is the polar representation of a complex number? Corresponding to x plus iy, corresponding to complex number x plus iy, the polar representation in the form of p of r comma theta. That means polar form. That means the x comma y we are presenting as a variable of r and theta. As z is equal to r into cos theta plus I sin theta. R is, what is the R? Modulus of z, modulus of complex number z. That is under root of x square plus y square. And theta is called amplitude or argument of z. That is theta is equal to argument of z or amplitude of z or argument of z is equals to, that is theta is equals to tan inverse of y by x. Tan inverse of y by x. So this is the polar representation of a complex number. Okay. If it is lies in first quadrant, this is enough for us. If it is lies in second quadrant, what is the answer? If it is lies in second quadrant, same point B. Here angle is we are measuring from positive x-axis to here, right? Positive x-axis to here. So what we are getting is the angle up to here, Positive x-axis to this OP line. This is the angle. So this OX is the negative. This is the negative x-axis. This is the y. This is minus x we are writing. This is the r. But length is positive. Why I written minus x? It is on the negative x-axis. For the direction only, I present with negative. A modulus value is the length of the circle is positive only. Remember that. Here you see tan theta is equals to what we are getting here? Theta is equals to tan inverse of here y by x, y by minus x. Nothing but minus y by x. Minus y by x means tan inverse of minus y by x. In second year already we know this one. Otherwise we do one thing. How I getting? You see, tan theta is equals to what y by x we know. Here x is negative, so minus y by x. So this is minus y by x we are writing. Minus y by x we are writing. So tan theta value is negative. In which quadrant? Second and fourth quadrant. Second quadrant equivalent angle is pi minus theta. So I am writing this is next step minus tan theta is equals to y by x. Minus tan theta is equals to tan pi minus theta. This is equals to y by x. Now pi minus theta is equal to tan inverse of y by x. Now pi minus tan inverse of y by x is equal to theta. Understood? That means so the complex number is in second, it belongs to second quadrant. The amplitude is equal to pi minus tan inverse of y by x. What about third quadrant, fourth quadrant? You see, that means here theta have different angles. You see, here if it is acute angle only theta. If it is obtuse angle, that means above 90, we are getting pi minus something like that. That means in theta we have different angle. Where to where? 0 to 2 pi are getting. 0 to 2 pi are getting. Up to one rotation is finished, after that 2 pi plus something we are getting. That means the theta values are different values we are getting. So the values which are lies between minus pi less than or equal to minus pi less than theta less than or equals to pi. These values are called principal values of amplitude. These principal values, the inverse trigonometric functions. So this tan theta equal to minus tan theta. Why we written tan of pi minus theta? Clearly we will discuss in second video in the chapter inverse trigonometric function. In inverse trigonometric function completely we will study about this inverse trigonometric function. When we are taking minus tan theta is equals to pi tan of pi minus theta. When we are taking minus tan theta is equals to tan of 2 pi minus theta. These are all things we will discuss in second video. Just for idea, for if it is complex number is like in second quadrant, we are writing theta equals to pi minus tan inverse of y by x. So you may get doubt. So why we are writing pi minus tan inverse of y by x? So that I proved here. How if it is like in second quadrant, this complete angle is 90 above is there. 90 above means second quadrant. So that is equals to minus y by x. So second quadrant equivalent angle. So minus tan theta equivalent angle is tan of pi minus theta. So that I get. Just to remember this one, theta is like in second quadrant. So the amplitude is pi minus tan inverse of y by x. So here minus pi less than theta less than pi less than or equals to pi. These values are called principal values of amplitude. Principal values, general values, all those things we will discuss in second video. Just remember that. So similarly, If it is lies in third quadrant, if it is lies in fourth quadrant, what are the absolute values? We will see now. As a formulas I am writing now. Z is equal to x plus iy is a complex number. Is a complex number. Then first one, the point in the Argand plane. In the Argand plane, P is equals to x comma y. Second one, polar form or trigonometric form. Polar form of complex number. Complex number. Z is equal to x plus iy is equal, otherwise z is equal to r into cos theta plus I sin theta. Right? Here r is equal to modulus of z and theta is amplitude of z or argument of z. Third one, in first A, question A, T, that means Z, complex number Z. Z of T means what? Z is a complex number corresponding to complex number Z. There is a point P. Lies in Q1. Then amplitude of Z or argument of Z. Otherwise, directly I am writing theta. Theta is what? Amplitude or argument. Theta is equals to tan inverse of y by x modulus. Tan inverse of y by x modulus. If it is second one B, Z of P lies in Q2. Then theta is equals to pi minus tan inverse of y by x mod. If it is lies in Z of P lies in Q3, then theta is equals to minus pi plus tan inverse of modulus of y by z, y by x. Next B, Z of P lies in Q4, then theta is equals to minus tan inverse of z minus tan inverse of modulus of y by z. E Z of P lies on positive x axis, theta equal to 0. Next to F, Z of P lies on negative x axis, theta is equals to pi. Next G, Z of P lies on positive y axis, theta is equals to pi by 2. Next to H, Z of P lies on negative y axis, theta is equals to minus pi by 2. So in this video you have to remember these things only. More than enough. For remembering this one, more than enough. Just you have to remember this one. Just so what we discussed now, just I explained about the Argand plane and polar form of a complex number, everything I explained. In shortcut form, you see what you have to remember in this video. Just z is equal to express iy is a complex number. So what is the point in the Argand plane? P is equal to x comma y. That's it. For example, z is equal to 2 minus 3i. What is the point P? 2 comma minus 3. That's it. For example, z is equal to 6. What is the point? 6 comma 0, because there is no imaginary. So 6 comma 0. So you have to remember that one. That's it. Next, polar representation. Z is equal to express iy is a polar representation. Right? The corresponding point P is x comma y. The polar form of the complex number z is equal to r into cos theta plus I sin theta. What is the r? Modulus. Nothing but square root of x square plus y square. Next to theta. What is the theta? Theta is called what here? Amplitude or argument of z of complex number. Right? So here, what is the theta formula? It is depends on the quadrant. Clearly it is depends on the quadrant. Why it is depends on the quadrant? Already I explained. If the point P lies in first quadrant, we are getting different angle. If it is lies in second quadrant, different angle, third, fourth quadrant, and lies on the axis also, we are getting different angles. So depends on the point P, nothing but the complex number. We are getting different amplitudes. What are they? If it is lies in first quadrant, the amplitude is equal to tan inverse of minus y by z. Theta equal to tan inverse of modulus of y by x. If it is lies in second quadrant, theta is equal to pi minus tan inverse of modulus of y by x. If it is lies in third quadrant, theta equal to minus pi plus tan inverse of y by x. So you may get doubt, sir, why you are saying that minus pi? So what about the complex number? The complex for the complex number, argument or amplitude, nothing but theta. Principal values. Principal values means that range, general solution. Principal values. Principal values means which are lies in specified interval. Those values are called principal values. That means they have some principles. Theta have some principles. That means what is that? Which is lies between minus pi to plus pi. Minus pi to plus pi, including pi also. Minus 180 to plus 180, including 180. These values are called principal values. Principal values. Principal values, right? These principal values. So these principal values. So that means that every theta value we have to represent. We have to give the answer in the interval of minus pi to plus pi only. So that if theta is, that means the complex number z, that means z of t lies in third quadrant. We are generally angle we are measuring with always positive x-axis. It may clockwise direction or anti-clockwise direction. Compulsory we have to measuring with the positive x-axis only. So positive x-axis we are measuring from positive x-axis. This is the 180. Third quadrant means 180 to 270 is there. But what is the principal value of z theta? Minus 180 to plus 180 only. This is the more than 180. So that I am measuring in clockwise direction. Clockwise direction angles are called negative angles. Right? So if we measuring the angle in clockwise direction, those angles we are taking as a negative angles. So it is a negative angle. Up to here minus 180. But here 180 to 270 is there. So minus 182. If we count this one, minus 5. This is a minus 5. That means this angle lies between, third quadrant angle lies between minus 5 to pi by 2 means minus by this one. If you add some value, this comes to third quadrant. So that minus pi plus tan inverse of pi by x and written. Clear? So here this one just fourth quadrant tan inverse lies in directly it is lies in fourth quadrant minus of some value. Less than of 1921. So no need to add, no need to subtract. Directly we are getting minus of tan inverse of modulus of pi by x. Next, if it is lies on positive x axis, angle between x axis and x axis is 0. So 0. Next y axis. Angle between x axis and y axis, that is pi by 2. If it is lies on negative x axis, so this is 180 straight line angle. It's 180. If it is lies on negative y axis, this is negative y axis means this is, if you measure any clockwise and anti-clockwise direction, that is 270. So more than 180. So that I am taking ulta clockwise direction. So it is minus pi by 2. So minus pi by 2. Clear? The amplitude values in quadrants, and on the coordinate axis also we have. Just you have to remember these tables carefully, then easily we can solve the problems. Right? You have to just you take one screenshot and you note it these formulas in your rough sheet and immediately you practice those. Right? Now, how we will say that the point, nothing but the complex number lies in quadrant. We will see some examples. For example, see, z is equal to 1 plus 2i is there. The point P is equal to 1 comma. Lies in which quadrant? Positive x axis, positive y axis means first quadrant. If it is z is equal to 1 minus 2i is there. The point P is equal to what? 1 comma minus 2. Lies in which quadrant? This is the fourth quadrant. Right? Z is equal to minus 1 plus 2i. That is point P is equal to what? Minus 1 comma 2. Belongs to second quadrant. Z is equal to minus 1 minus 2i. The point P is equal to minus 2 minus 1 comma minus 2. That is belongs to third quadrant. That means so just you take this one also one screenshot and you practice this. So the general form x comma y. Here this is minus x comma y. This is the quadrant 1. This is quadrant 2, second quadrant, third quadrant, fourth quadrant. Next in third quadrant I find minus x comma minus 1. Fourth quadrant x comma minus 1. On the positive x axis x comma 0. On negative x axis minus x comma 0. Positive y axis 0 comma y. Negative y axis 0 comma minus 1. First quadrant amplitude is tan inverse of y by z theta. Here theta is equals to pi minus tan inverse of modulus of y by z. Third quadrant theta is equals to minus pi plus tan inverse of y by z mod. Fourth quadrant theta is equals to minus tan inverse of y by x. So just remember these table from this diagram. Easily we will remember. Extend this one also. Now you take your screenshot and you practice this one. Okay, this tan inverse always is the positive one, and you have to remember this one. Tan inverse of 0 is equal to 0, and 0 so everything already we given clearly. angles only we need. Tan inverse of 1 by root 3 is equals to pi by 6, and tan inverse of 1 is equals to pi by 4. Tan inverse of root 3 is pi by 3. Next to 90, no. These three values, so you have to remember these three values also. Right? Before formulas and this table and these values. You remember this one? Easily we will solve next exercise. Right?